Hello guys, welcome to the Pure Physics Paper 2 revision. Remember, these questions were posted in the WhatsApp group so that you answer them and submit the work for checking so that I can be able to notify or rather notice any mistakes that you could be making so that I provide the correct way of answering the questions to avoid you repeating the errors or making these errors in the examinations, which may cost you marks. All right, so in this video we are just going to do that, where I'm going to show you how you should have answered or you could have answered some of the questions in this assignment or revision. Okay, so let's go straight into this revision without wasting much of our time. Okay, so we had this question here. So this question came from a 2018 paper. So this question was picked from a 2018 paper, and this was actually from section A. So the question was like, answer all the questions in the spaces provided on the question paper, meaning that you have to answer within the spaces that are provided. So question 1 reads, figure 1.1 shows a measuring device. Okay, so this figure 0.1 here shows a measuring device, this one here. All right, so it is a measuring device. It means that it is a device which is used to measure a physical quantity. It could be mass, length, time, or temperature, and so forth and so on. So the question here says, name the instrument. So when you look at this figure here, it is coming from a certain instrument. It is part of a certain instrument. Okay, so the name of this instrument is a micrometer screw gauge. So the name would be micrometer screw gauge. Micrometer screw gauge. Okay, so remember, this is how some questions on micrometer screw gauge come. Okay, so this was simple question. This was a simple question and it carried 1 mark. Then B says, what is the reading shown? So here B is asking you to find the reading. Now, reading should be found using this formula. Reading, which is R, is equal to, what we have here is the main scale reading. So you read on this part. This part is called main scale. Okay, it is main scale. Okay, which I like abbreviating as the capital M and the capital S. Then we also read on this part here, which we call secular scale. Okay, so this is a secular scale, and then which we also abbreviate as the capital C and small, and capital S again, like that. Okay, now the formula is this. So reading, which is R, is equal to main scale, then we say plus, open brackets, secular scale times what we call least count. This is the formula which I use myself. I like using this formula because it is straightforward. It doesn't confuse me. So I can write the formula here to say reading is equal to main scale plus, open brackets, I'll say secular scale times least count. So a least count Least count, which is the LC, is the smallest dimension that an instrument is able to measure accurately. And for a micrometer screw gauge, least count is a standard value. Mostly least count for a micrometer screw gauge is equal to, if it is in millimeters as it is here, it means that the least count is 0.01 millimeter. So when you look at it, it is a very small dimension. So now let us look at it also main scale reading. Main scale reading can be obtained by reading the last digit here. So this last digit here is actually 6. So meaning that the main scale reading is 6 millimeters. Then we also need to read the secular scale. So the secular scale reading is actually read from a value from a line. This line here, you see this line, and this line here, this is where you read from. When this line and the other line here, they make a straight line, then it signifies where you are supposed to read from. So you read from bottom to top. So if you have 20, for example, 20, you say this is 21, 22, 23, then 24, where this arrow is pointing. So it is pointing at 24, so meaning that you have there 24. Okay, so this 24, don't give it any unit, then you just say okay, equals, you have now main scale 6 meters, then plus, then open brackets, secular scale, you have 24, then times least count, which is 0.01 millimeters. Then you will evaluate what is in the brackets. You'll say 6 millimeters plus, then you say 24 times 0.01 millimeters, you get 0.24 millimeters. Then you add, you say 6 millimeters plus 0.24 millimeters, you get 6.24 millimeters. So meaning the reading will be 6.24 millimeters. So always remember to put units, guys. Okay, so this is it, the correct answer. Then we come to C. C is saying state 2 precautions taken when using the instrument in order to prevent errors. So when you are using this instrument here, the micrometer screw gauge, there are some precautionary measures or care which is taken to avoid making errors when using this instrument. So what are those precautions that are taken to avoid this instrument from making errors when it is being used to measure length, for instance? So number one, because this instrument is very sensitive, you need to clean the spindle and the anvil to remove any dust particle which can be read together with the object if not removed. Because if you don't wipe and it is discovered that the edges of the spindle and anvil contain maybe some dust particles, so these dust particles will be read together with the object that is being measured, and this can result into wrong measurement. So you need to clean. So the first precaution which can be made is to clean. So you clean both the anvil and spindle. before starting to use it. Then the second one is to check for zero error. So a zero error, as we always say, it is an error that an apparatus introduces in the measurement as a result of not starting from zero. Okay, so sometimes apparatus can have a zero error where they give you a reading when they are not measuring anything. They can give you a reading when they are not measuring anything. So if you get an instrument, for instance a micrometer screw gauge, and begin using it without checking for the zero errors, it may give you an error in terms of that reading. So here you have to check for the zero error. You check for the zero error. And you account for it, if found. So if you discover that this particular apparatus or device has got a zero error, then you need to account for it. Okay, maybe you subtract it from the final reading if the zero error was positive, or you add a value to the final reading if the zero error was negative. Okay, so again, you can also get the reading at the right angle to avoid parallax error. Okay, so this is how you should have answered this question. Then let's move to another question. So the next question here says a pebble is thrown vertically upwards with initial speed of 10 meters per second. After reaching its maximum height, it falls freely to its starting point. Take G as 10 meters per second square. On the grid below, plot a velocity time graph for the motion of the pebble. So a pebble, it could be a stone, something like that. I'm not too sure what this pebble is, but it can be just a piece of something or a stone. So it is thrown vertically upwards with the initial speed of 10 meters per second. Then they're saying after reaching its maximum height, it falls freely to its starting point. Then they're saying take G as 10 meters per second square. Then they're saying on the grid below, plot a velocity time graph for the motion of the pebble. So, a velocity time graph, they're talking about velocity time graph. Should have the vertical axis, this vertical axis here. Let me try to draw something here. The vertical axis here. Okay. This is the vertical axis. I don't know why this one. Okay, I want to rotate it so that it becomes Okay, so it's unable to give me what I want, so I may just delete it. I'm sure. Let me just maybe delete it. Let me just delete it. So I have deleted it. Let's just consider this one as the velocity. Velocity should be in meters per second. Then the horizontal one, this is time. So let's say this is time t in seconds. So we need to know time here. You see, we were just given what? We were just given initial velocity. So a pebble is thrown vertically upwards with initial speed of 10. So we will use like this equation here, like we have actually v is equal to u plus at. So this changes if you are throwing something upward, you are throwing it with an initial velocity. So at maximum height, so when you throw something, it means you are throwing it with initial velocity. That's why I've said initial velocity is 10 meters per second. But the maximum velocity is 0. At that height, maximum height, it will reach, then the final velocity is 0. Then acceleration here changes to g. Okay, sorry. So acceleration changes to g. Okay, this part of my computer doesn't write properly. I don't know why. So changes to g. So since it changes to g, why? Because the motion is happening under gravity. So the equation changes to 0. Here where there's v, we'll put 0 equals, then we'll have u plus, then we'll have this g, actually it's negative because you're throwing it upward. So it will be negative g t. So it will be like 0 is equal to u minus gt. So you make u the subject of the formula. So u negative is going to be equal to negative gt. Then you multiply by negative both sides, so you get rid of it. So you have u is equal to gt. So let's find time. So we'll divide by 0, or by t, by g, I mean, even here by g. So g goes here, so time is going to be equal to like u over g. So see, initial velocity is 10. So here we'll say initial velocity is 10 and g is 10 already there. G is 10. So we'll substitute to same equals 10 over 10. Okay, 10 over 10, it is going to give us 1. So the time will be 1. Now, so here is now the catch. So you come up with a table. Let me come up with a table like this. So let me maybe cut it like this. So we have our initial velocity, and then we have time here. Okay, we just have velocity here, not initial. Sorry, that is quite misleading. So here we have just velocity. Okay, so now we'll do like this. Initial, it means time was 0. When time was 0, our initial velocity was 10. They threw it with it 10. That's what you should know. That's the logic. So our initial our velocity was 10. Now when time became 1, our velocity went to 0. Went to 0 because this, for it to move from the bottom with initial velocity to go to the maximum, where the velocity at the maximum is 0, the time that it took was 1. So 1 will be 0 here. So in our plotting now, we will have time here 0. Maybe we decide to make it from here to there 1. I'll just say 4 boxes, 1, 2, 3, 4, 5, 1. Okay, then what I'm going to do also here is just to decide that maybe 3 boxes, or actually how many boxes? 5, they become 10. So I'll say 1, 2, 3, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so okay, let's bring it up to here. 6, 7, 8, 9, 10. So here, let me just wrap this part and put 10 here. Okay, so now this is the initial velocity. So at 0, the initial velocity was that. So in plotting, the graph will just be like this. That will be our graph. Okay, because 0, 10, it will be where I've put here. Then 1, 0, it will be here. So you join the two. That's the graph. Okay, so that's how the graph is going to be. So this is how you get this graph. So when you say on the grid below, plot a velocity time graph for the motion of the pebble, 3 marks. So this one deserved about maybe 4 marks or 5 marks, because I don't think it was as straightforward. I think many pupils got this one wrong because the question was quite twisted. Then the same B, from the graph you have plotted in B, in A, calculate A, the maximum height the pebble reaches. So maximum height the pebble reaches. So since it was thrown upward, so let me solve also from here. Okay, so I'll drive the formulas. So you remember these come from the same formulas, like let's say we try to use this formula which says I think we have time 1 there, but let's say we have this formula which says v squared is equal to u squared plus 2as. So when objects are undergoing free falling, or they're undergoing vertical motion, you have also to understand the way we set the standard to same. V is equal to 0 if it is thrown upward, vertically upward. Then GA becomes negative G. Then S becomes height. So I substitute these into the equation because I want to come up with the formula. I've not memorized the formulas, but I know how to how to drive them. So have, where there's v squared, we'll have 0 squared is equal to u squared plus 2 then open brackets, A becomes negative G, then close bracket, S becomes height. Then this becomes 0 is equal to U squared, then positive negative, it will be negative, then 2GH. So we make U the subject of the formula, it will be like U squared is equal to negative, actually U squared is equal to negative 2 then GH. We multiply by negative both sides to get rid of that negative. We get U squared is equal to 2GH. So this becomes the formula as it is. Sometimes we square root this side and this side so that we have U squared, not U squared, like U is equal to the square root of 2 then GH, like that. But this is the formula I wanted, but I'll leave it on this stage here. This is the formula I wanted, so we will leave it at this stage. So we'll use this formula which says U squared is equal to 2GH. So we already have the data. We have U is equal to 10, then we have G also as 10, then we have height as question mark. So if we substitute, I'll say here 10 squared is equal to 2 times what? 10 times H. So this one will be 100 is equal to 2 times 10, 20 H. Then I'm looking for H, I'll divide by 20, even here by 20, so that 20 into 20 goes, so that I'll remain with H now is equal to 20 into 100, 5 meters. So the distance here will be 5 meters. Okay? Then Roman numeral 2, they are saying the acceleration of the pebble as it was moving upward. If I am to think well, the acceleration must be 10 itself. So, but then they're saying we calculate. So, how are we going to calculate? Because from what I know, it is going with an acceleration of, okay, let's use the formula, that formula that I drove as U is equal to GT. Okay? So, what we are going to do is we know time, data, we know time, we found it to be 1, and then U is equal to 10. So if we were to substitute here, we'll say U was 10 equals, then here we'll have G, which is acceleration, we don't know, times T, which is 1. You'll find that to be 10 is equal to G times 1, it is G. So that acceleration, just as I said, is equal to 10. So it will be 10 meters per second square. Okay. Then compare your answer in B to the value of G. If I compare, they are the same, unless if I don't know how to solve this question at this level. But from what I can see, I've solved it well, and then the answer, the values are the same. So you can say the values are the same. because we are comparing, so they are the same. Okay, then let's move to the next question. The next question here, 3, says figure 3.3 shows a bed that folds against the wall during the day. So we have the bed that folds against the wall during the day. So this question is already coming from moments, and we have a bed, so study it. You have the wall, the hinge, then we have the leg of the bed. Okay, so the bed, when it is folding, it goes like this, then it folds. So we have a pivot there. Okay, then let's see the question as it goes. Then it's saying when horizontal, the bed is supported on one side by a hinge and on the other side by 2 legs. So it has 2 legs, one is behind this leg here. Then they're saying the weight of the bed W acts through the center of the mass is, let me read again. The weight of the bed W acts through the center of mass, which is 0.35 meters. So the weight acts here. This is the weight. Then we are saying from the hinge, take G as 10 Newton per kg. Then the same Roman numeral, A, state the principle of moment. So the principal moment states that the sum of the anticlockwise moment is equal to the sum of the anticlockwise moment for an object in equilibrium. Okay, so it starts to say for an object in equilibrium, the sum of the clockwise moment is equal to the sum of the anticlockwise moment. Yeah, so that's how you state the principle of moment. You say for an object in equilibrium, the sum of the clockwise moment is equal to the sum of the anti-clockwise moment. And this one, they decided to give it 1 mark. Then we go to B. They're saying, so we are saying for an object in equilibrium, the sum of the clockwise moment is equal to the sum of the anticlockwise moment. Then B, they're saying if the mass of the bed in figure 3.3 is 26 kg, calculate the weight W of the bed. Okay, so if we are given mass and asked to calculate weight, we know the formula to say weight, capital W, is equal to mass times acceleration due to gravity. So mass, according to the data given, mass now is equal to what? This one here, 26 kg, and acceleration due to gravity was given already as 10 Newton per kg. Then we can substitute where we say equals, so mass we put 26 kg, then times acceleration due to gravity is 10 Newton per kg. So we know that the kg and the kg can cancel. So 26 times 10, it will be 260. So the unit here will be Newton as the weight. So here we shall put 260 Newton as the weight. Then 2 marks this one. Good. Then we move on to C, where they are saying determine the size of the total upward force exerted on the bed by the 2 legs when the bed is horizontal. So we determine the size of the total upward force exerted on the bed by the 2 legs when the bed is horizontal. So we come back here. So what they're asking is the upward force here, F, which these legs exert on the bed when it is in this horizontal position here. So for us to be able to know the answer here, we must apply the principle of moment, considering that we have the pivot here. Okay, so we have the pivot, meaning this is where the rotational motion is occurring from. So using the principle of moment, we can have clockwise moment. So the reference is this one. So we can say this force, we can say our force, for instance, times distance of this force from the pivot, I will say distance 1, is equal to, then what I'm going to say, because there are 2 moments, this force upward causes an anticlockwise moment, but we have this force which is the weight, it is pointing downward. As you can see, this arrow here is pointing downward. So this one causes an anticlockwise moment or clockwise moment. So there are 2 forces then. So once we identify those forces, then it becomes easy. So it will be like W again as another force times its distance from the pivot, which is D2. So here we'll put the distance of W from the pivot here as D1, D2. I've called this one as D2 from here to the pivot there. Then of this force to the pivot here, it is total from there to there. So this one you call it as D1. I decided to call it D1. So you find that D1, it will be a total of 0.35 plus 30 plus 0.3. So D1 is going to be equal to 0.35 plus 0.30. So when we add these, we get 0 plus 3 plus 5, 5, then 3 plus 3, 6. So 0.0. So it will be 0.65 D1. Then this D2 is just 0.35. So substitute to say force times, then D1 we are saying 0.65 equals, then I'll say here W times D2 is just 0.35. So this is our formula. You have seen, using principle of moment. So we said F, which they are looking for, times D1 is equal to W, which is another force, times D2. So I said, okay, F times this one, D1 was 0.65 equals, then W is already weight, which is 260. So say 260 times D2 here was 0.35. So let me see if I can get a calculator. just want to get a calculator so that we can see if we can be able to find the answer. Okay, so now, sorry, so now what we are going to do is this. So we have a calculator here. So we are going to say this f times 0.65, it will just be 0.65 f is equal to, so say 260 times 0.35. It is going to be 91. So to get f, we'll divide by 0.65, even here 0.65, so that one goes, will remain with f is equal to, so that 91 divided by 0.65, we are getting like 140, so it will be 140 Newton. That will be the force they are looking for. So yeah, determine the horizontal force. That is the answer. So we move on to the next question. So I'm sure this was the last question. So the last question here says 4M figure 4.1 shows an electric motor used to lift a load. So this is an electric motor, as you can see, used to lift a load here. So when this one rotates, the load begin going upward. Okay, so this is it there. So then we go down to see the question. The question says the load of weight 500 newtons is raised through a vertical height of 3.5 meters. So there is actually a vertical height. Okay, so what I can see is like my computer is now performing, okay, because the battery is done. So let me do it very quickly. It's even now trying to freeze. What is going on? What is going on? Okay, so let's hope we will do it fast. So the same, through a vertical height of 3.5 meters at a constant rate. Given that the efficiency of the electric motor is 65%, calculate the gain in gravitational potential energy of the load. So gravitational, which is gravitational potential energy, the same way we find potential energy is equal to mass times acceleration due to gravity times height. So substitute this mg is actually the weight, this one, so it will just be 500 times height, which is 3.5. So then we shall now do what? We shall now find the answer by saying 500 times 3.5 equals 1750. So 1750 joules as the gravitational. So this one is done. Then we come to this one here, calculate the work input. So this one, calculate the work input, they never gave us any information to use. So the information to use is to use efficiency. Efficiency is equal to what we call work output over work input. First, let me see. Maybe there could be something I'm missing. No, yeah. So now the work output is what calculates the gain in the gravitational potential energy. So the work output is what we have calculated actually here. So if we are to make everything the subject of the formula, so this one times 100% here actually. So if we are to make work input the subject of the formula, it will be like work, I would just say work input like that, W work input is equal to, so it is going to be work output or output over, I will say efficiency let's say efficiency, yeah, times 100. I think the 100 can remain this side, there will be no problem. So say equals, so we'll substitute work output is this one here, the same one we calculated. So it will be 1750 divided by efficiency was provided as 65. So you put your 65 there, percent times 100%. So if we do the calculation correctly, we'll do that one divided by 100 equals times 65. We'll be getting like 1137.5 joules. So this one will be the work input. Now, yeah, so that's the answer. Then they're saying show that the efficiency is 65%. So to show 65%, you just get this one. Efficiency is equal to 1750 over this you have found here, 1137.5 times 100. You find that it will come out as 75 or 65%. Okay, then we move on to B, where they're saying solar energy is a renewable form of energy. What is meant by, okay, so we are running out of battery, so I'll just explain what is meant by renewable energy. Renewable energy, it's energy that can be energy which is produced by renewable resources. Then give one challenge of using solar energy. Solar energy is affected by weather. When there are clouds, for instance, the energy is affected. All right, so we end here, guys, due to the battery, until we meet again in the next lesson. For now,